All right, good morning, everyone. Before we start, and I will remind you that you guys, of course, you have all the information on Brightspace. So our final exam. Okay, I'm gonna give a few minutes for everybody to connect. In the meantime, those who have questions about the homework, please put them on chat. Okay. All right, so your final exam is a week from today, so it's going to be Wednesday, May 5. The exam will open at 9:45 and closes at 12:45. So it's 3 hours, gives you enough time to, to print, to scan, to do anything you like to do. I want the camera on during the exam. The link for the final is the same as the link for your regular class. So it is the same thing we will be using. The best way you guys will review for the exam is you go over your quizzes. You have the solution to everything. So you go over your exams, and you're going to do some of that today. I have no idea how many questions the final will have. Ask me before the exam, because I write the exam the night before. So go over your exam and then finally go over the review. Okay, and on Brightspace, I gave you the review. Also on Brightspace, if you guys look very carefully in the module what's written review for exams, I also have a formula sheet for every formula we've seen. Okay, this can be very handy for you. Okay, so formula sheet also on the content page on Brightspace. Okay, all right, what else? The office hours, everything is actually different next week because I'm giving exams at different time. For this class, I will give office hours Tuesday. It means the day before the exam. So it's going to give me May 4. And I will give office hours from 9 to 11. So you guys, you can stop by anytime between 9 and 11. And the link for the office hours will be on Brightspace. So I will put a clear link for you on Brightspace. Okay. All right, any questions from your partner? Any question about the homework? That is sign, ellipses, completing squares, anything of that matters. Okay, so today, as I said, as I said last time, we started the review, and today we're gonna keep going with the review. So my idea is to review some problems from exam 1 and exam 2, the one that you had trouble with. This doesn't mean that that's the only thing you will have on your exam. On your exam, you will have everything on the review. So you have to make sure you know all what's in the review. So let's see, last time we did the main definition. Can you go over completing a square? Aaron, can you give me a problem quickly? I don't have them in front of me.
I didn't mean like on our homework. I just meant any problem, just like a review.
Okay. Those I cannot make up from the top of my head because I can mess it up for you. Let me give me 1 minute and I will pick up a problem. Okay.
Okay, thanks.
Yeah, because those problems, if I just write usually I can do anything, but this one, no, because, so I'm going to take the following equation. Let us say x squared plus 2y squared. I'm just making up something that I think would work. Plus 4y plus 7 equal to 0. Okay. It looks really messy, but is 24 completing the square, Rebecca? Rebecca? No, so what's 24? On the review. Ooh, okay. So let's do that. Let's do that, and then I will look up number 24 because I did. Okay, so we're gonna first do this, and then I go back. It's your hour. You guys can ask any question you want. So it's free for you guys. So I'm gonna take this one, and then I will do it. So the first step is put all the x's together. So I'm putting them together. I'm just rearranging. I'm not doing anything for y. And then the constant terms, I'm moving it to this side. Okay? Make sense? Please, if you don't follow, let me know. And then I start completing the squares. Now, if the coefficient of x squared is 1, the problem is simple. If it's not 1, we have to factor it out. So this, I'm going to write it. So I'm not starting completing the square. I'm making it ready to be completed. Now, if I factor out the 2, this is a y squared, and I factor out the 2, this is 2y equal minus 7. All right. And now I'm going to complete the square. Okay, this piece. What shall I add to complete? What x multiplied by? Exactly. It's 6 divided by 2, it's 3. So I'm going to add the 9 in here. And I immediately compensate by adding the 9 to the other side. Now the piece in between. What should I add here? Y multiplied by 2. Divide this by 2, which gives me a 1. Square it, it's a 1. And then you add it. All right. Now what shall I add here? When I add 1 here, what shall I add from the other side? Please quickly. Yeah, because basically I am multiplying by 2. Because I have this 2 here. It means basically I'm multiplying by 2 plus the 2. And now the rest should be relatively simple. This piece here will become x minus 3 squared. Okay, what goes in here is the coefficient of x divided by 2. If this is 6, what goes in here is half of that. So now if you take the expression x minus 3 squared and you actually distribute, you should get exactly that. Plus 2 times. Now this piece here will be the y. What should go here? That's a plus. You get a plus here, half of the coefficient. So that's going to be a 1 equal. Now minus 7 plus 9. So it's going to give me 2. 2 plus 2 is equal to 4. Okay. So we're almost equation of an ellipse, which is shifted. But now we have to divide by 4 to get exactly an ellipse. I'm going to divide by 4. And I will get x minus 3 squared. I divide across by 4 plus. All right, so this is going to be divided by 4. This is going to be divided by 4, and this is going to be divided by 4. Now, this piece here will give me a 1. That's what I want. Right here, 4 is 2 times 2. So the 2 will be simplified, and I will be left with 2 there. Okay, so that's really what how we complete. In this square, in this problem, the a squared is 4. It means my a is 2. The b squared is 2. It means my b is the square root of 2. So a is larger than b. It means it's going to be stretched, elongated horizontally. And sorry, I forgot the center. The center is going to be 3 from here and minus 1. Okay. And the rest is we take all this info and we put them on a graph. Let's see what I mean by that. The center is 1, 2, 3, minus 1. That's the center. A is how far away we move from the center. It means we're going to move 2 units from here, 2 units from here. This is the A in the picture. The B is the square root of 2. Now the square root of 2 is almost 1.4. Okay, so we're going to go the square root of 2. So the question is going to be my ellipse. And the problem. No, absolutely everything on the final, absolutely everything. You guys have a week to study. You sit down and study, absolutely everything. All right. Rebecca, no, who asked this question? Not Rebecca. Erin, does it make sense?
Yeah, it does. Thank you.
So this takes care of that. Now, let me go back to Rebecca. Rebecca, what is 24 about? Can you tell us? I lost Rebecca. All right. So let me keep the review from last time. So last time we actually started the review with you, and I reminded you, and if you don't remember that, you're in deep trouble. The definition of sine and cosine. Oh, don't worry about asymptote. Do not worry about asymptote. This problem has to do with hyperbola, and I dropped hyperbola. Okay, so do not worry about that questions. I should remove it. All right, so last time we defined, I reminded you the definition of the sine and the cosine, and the sine was the x, and so the sine, so that's to my point P, and the sine was the y coordinate, and the cosine was the x coordinate. Okay, and you guys should go over the problem that we started last time. And then we talk about the graph of those functions. And the tangent has one definition. I never change it. The tangent is the sine over the cosine, whether you are in a right triangle or not, which is the y over the x. Now the graphs of the sine and cosine, that of course those has to be, usually, as I said, I force my student to memorize all those graphs because they will come up with you absolutely continuously for those who will pursue sciences. So if I put the value of the angle on the x-axis and the values of the sine on the y-axis, then the graph is going to be, the graph of sine start at 0, go up and go down. And it's periodic of period 2 pi, because if you take an angle, then you take this angle and you go back to pi, you're not changing the y coordinate of the point. So it's, and then the graph will start repeating. It's periodic, periodic, and keep repeating. And repeat all the way through. So that's the sine. So it starts here. The cosine start right there at t equal to 0. It's going to go down, it goes up. And this is the 2 pi. And then the cosine graph will start repeating itself, and it repeats itself all the time. So this is minus 2 pi, and this is the 2 pi. Okay, so this is the graph of the cosine. And the graph is totally coming from the definition. I mean, that's where this is coming from. Right? Now, second piece we saw, and is what we call the sinusoidal function, and that's the one I will be working with it. So sinusoidal function, sinusoidal function. Okay, so sorry, I have to mute because I hear voices in the background. Okay, those are functions that look like the sine of cosine, but what happened is that we stretch them a little bit, we move them up, and we change the period. So the sinusoidal function, they are function of the following form. A sine of bt plus k, or a cosine of bt plus k. So I'm doing those because those are the ones we've done a while ago. All right. Now, for each one of them, the amplitude is A, okay, and the midline, the midline, that's easy, is y equal to k, and the period, that's important. The period is 2 pi over b, okay? And now we're gonna work out a problem like that. So it means this function, when you see it, if you wanna graph it, it looks like a sine, basically. The midline is y equal to k. It means it's the sign shifted by k. And then the periods change. The period becomes 2 pi over b, and then it's the sign which being stretched. Right, so with this in mind, I will go through a few problems from exam 1, which are basically relevant to this idea, because you will definitely be hit with those type of problems. All right, so exam 1, so I will tell you exactly what I am doing. Exam 1, so I'm going to look at not everything. It's your responsibility to go over everything. I'm just reviewing part of the material. I'm going to look at number 10, 11, and 12, okay, because they are very relevant to this piece. All right. So number 10 was, you have this function. It's total sinusoidal 2 pi t plus 4. Okay, and now here's the question. The question is, we have to find the amplitude. Then we need to find the midline. We need to find the period. And finally, the question was to sketch. Okay, so I will do that just to remind you everything. The amplitude is what sign is multiplied by, because multiplying by 3 will stretch vertically. So the amplitude is, that's my A, equal to 3. The midline is by how much we shifted up and down. So the midline here is the line y equal to 4. The period, it means how often, how long it takes for the function to repeat itself. So in this case, the b is what t multiplied by. That's the b, which is 2 pi. So the period is 2 pi over the b. It means 2 pi over 2 pi, which is a 1. Okay, so now the question is, so now I have all the picture, now we have to graph. So I will use a pencil so I can erase. And I wanted you to graph it over 2 periods. What do I mean by the graph? This is a sine function. It looks like a sine. And it's plus sign, not a minus sign. The midline is y equal to 4. So the way we're going to sketch, I first sketch the midline because it gives me an idea what's really happening. That's my midline. And we know it's like sine, and we know that's the sign. The sign goes like that. That's how the sign. It's positive because I have a positive number here. It means it's not going to go this way. It's exactly like the sign, but stretched by 3. So it's the sign. We start from here at the midline. We stretch by 3. It means we go up 3 units, which give me at 7 right here. And then we go back down. Another 3, so we're not going to hit here. So that's going to be a 1. And then back up here. And the question is, the period is 1. It means the cycle finish at 1. This is 1 right there. And then another period means you go up, you go back down, you go up, and this is it 2. That's what it means. It repeats itself every 1 unit. It repeats itself. So this is really 1 cycle. And that's how this graph would look like. And this is the amplitude from here to here. That's my 3. And that's my midline. Okay, I'm trying to refresh your memory, and it's up to you to take it and to work with all those problems. Okay, another problem I'm going to do also relative to that. Actually, I would like to do a few problems. I will do number 11 from your exam as well. Please let me know if I'm going fast or... So again, I am exam 1. And I'm doing number 11. Now, number 11, I have to bring the exam in and because I need the graph. All right. Question. Yes, Kishan. What question do you have?
I remember you going over this, and you said one of them like it started at the midline, and then the other one.
Yes, the cosine start, the sine start at the midline. The cosine start at the top or at the bottom, depending if it's plus cosine or minus cosine.
Okay, thank you.
Okay, all right, very good. Now, find here And that's a slightly different problem. I'm not giving Q the formula in here. I am asking Q to find the formula for this function, okay? So, but to prepare you, I ask you to find the midline. I ask you to find the amplitude. I ask you to find the period. And then I'm gonna ask you to find the formula for it. All right, first the midline. As I told you before, either for the midline amplitude, you can either spot it, just look at it, or you can use a formula. So to find the midline or the amplitude, I need to find the maximum value of the function. So I look at the graph here, 0, 1, 2, 3. So the maximum is 3, and the minimum is -1. Okay, so what is the amplitude here? And what's the midline? Okay, all right. So this is -1 and this is 3. The midline is the one halfway through. So that's really my midline. It's the one halfway, it's the line which is halfway between the max and the mean. So you can either just look at it and tell me it's the line y equal to 1, or the formula for it is, sorry, y equal max plus the mean divided by 2. So I don't care whether you use the formula or you just look at it, but if I use that, I will get 3 minus 1 over 2, which is 1, which is we absolutely knew that. That's y equal to 1. And the amplitude is how far the max is from the midline. So the amplitude is from here to here. So you can, again, spot it, look at it, tell me 2, it's obvious, or you can use the formula, it's the max minus the mean over 2. And if you use the formula, make sure it makes sense, okay? And the max is 3, the mean is -1 over 2, so this is gonna give me 4 over 2, which is equal to 2, okay? Now the period. It's how long it takes to finish a cycle. So I start with the graph. So starting at 0, we're going down, we're going up. The cycle is not done. We're going up, we're going down. And then it starts again. Okay, so the period is from here and all the way to here. That's the period. And honestly, it doesn't matter where you start. You can start from here if you want for the period and ask yourself how long it's taking to finish. You're gonna get 7. So regardless where you start, you're gonna get 7. So that's the period, which is 7. Because after that, it starts repeating. So we're starting here, that's the main piece, and then it repeats after that. So the period is equal to 7. Okay, so now we're ready for the equation. And we have to be very careful. What's the equation? So the equation will be y equal, and the graph look like sine. Graph looks like, is it a sine or minus sign? We're starting at the midpoint, but we're going down. So the graph looks like minus the sign, not the sign. The sign go up and down. So the graph, the function is going to be, that's the general function. Sine bt plus k. And my job is to figure out every piece in here. So in my problem, this is going to be equal. -3, sorry. My amplitude is 2. That's my amplitude. The minus, because we're going down. Sine of. And this is, I'm going to keep it up because we're going to talk a little bit about that. Plus the k. K is the midline, which is 1. But the question is, what is b? B is not the period. B, and that's where the mistake that came out. B, write it in big letter, whatever you guys are doing. B is not the period. What is B? The relationship between B and the period is this. The period is 2 pi divided by B. That's the relationship. Or you can write it, if you do a little bit of math, or B is 2 pi over the period. So if you know B, you know the period, you use that. If you know the period, you know B, you use this. So that's really how we get the B. The B is not the period. So in my problem, what's the b? So in my problem, the b is 2 pi over 7. So this is going to give me 2 pi over 7 times the t. And that's the formula that will fit this equation. Okay, I will do only one more along those lines, and then I proceed to solving this equation. As I said, I'm reviewing part of the course, not the whole thing, the one that you struggle with the most, which is the crucial part. All right. Oops. Okay. Now the second one I'm going to do is number 12. Again, this is a function. And the question is find the midline, amplitude, period, and then give a formula for the function given by the following graph. All right, if I want to find midline, amplitude, period, everything, I need to figure out, first I figure out the max value, the minimum value. Okay, the maximum value, I gave it to you. It's 7. And the minimum value is also clear on the graph. Is -1. Okay, so the midline is the one halfway between here and here. So from here to here, I have 8. Okay, so this is going to be somewhere along this line. Okay, so let us find the midline. So what's the midline? What's the line? What's this line should be? Can you guys just look at it and figure it out? Can you look at it? From here to here, 8, it means, yeah, this is 4 from here to here, so this should be a 3. You forget it, we use the formula, midline. Y equal the max plus the mean divided by 2. 7 minus 1, 6 over 2, which is equal to 3. That's the midline. Sorry, if you guys don't see, let me know. It's your responsibility to let me know. All right, now the amplitude is how far we have from here to here. Amplitude is 4. Okay, now the period, because to find the equation, I need the period. What's the period in this problem? Now, I didn't give it to you a very direct way, but if we start from here, we're going to go up, down, all the way to here. And then the graph starts. So by analogy, what this value should be quickly. You guys should look at the graph. You should understand the graph. What value this should be? That should be 8. And that's by period. And after that, we're starting to repeat. So that's my cycle here. That's the period is 8. Okay, and then we start repeating. The graph is repeating itself. It's just like shifting it by 8 units, and the graph totally repeating itself. The period is 8. Now, does the graph look like sine or cosine? We're not starting at the midpoint, so that's a cosine, but we're starting at the bottom, minus cosine. Okay, so now let us build up the formula. Okay, so y equal. Okay, minus the amplitude is 4, minus 4. Cosine, I will keep this like that because always we have to think about it, plus the shift, which is a 3. So now I need the b. What's the b in my problem? The b is 2 pi over the period, as I said a minute ago. The b is not the period, it's 2 pi over the period. It means 2 pi over 8, which is pi over 4. Okay. So this is going to give me pi over 40 plus 3. It means if you take this function, you pick up your calculator and you graph it, you're going to get exactly that. So this represents this represents this. So this is the formula for this graph. Now, part B, I asked you simply, check that your formula agree with the value of the function given by the graph for the following values of x. all right? So it means I'm actually helping you to see, you know, are you getting the right formula? What do I mean by that? At t equal to 0, what does the graph gives me and what does your formula gives me? They should be the same. If they're not the same, it means something is really not right. According to the formula, if t is 0, as t is 0, the output is, so this is the graph. It tells me that y should be equal to -1. That's the graph. Now, what about the formula? Okay, according to my formula, y is minus cosine 4. If t is 0, it means I plug in 0 in here, plus 3. But cosine of 0 is 1. It's -4 plus 3. It's -1. They agree. Okay, so they have to agree because this formula should represent this graph. Now at t equal to 4, I'm going to do exactly the same thing. What the graph gives me and what the formula gives me, they should agree. So the graph, okay, t equal to 4, that's 4, 7. It means if t is 4, the graph is giving me 7. So that's 7 here. That's the graph. So y is 7. And now what about my formula? It means if I plug in 4, 4, t, what should I get? If I don't get 7, it means I'm doing something wrong. It means -4, pi over 4 cancel, cosine of pi plus 3. But let's remember that the cosine of pi, okay, pi is, if I go back to my unit circle, this is pi. The cosine is the x-coordinate. The x-coordinate is -1. So this will give me -4 times -1 plus 3, which is 7. If I don't get 7 here, it means that this rule, this formula do not represent the graph. Okay. All right. I will do 13 and then I will go back to one more problem along those lines, but with different contexts I would like to do. Number 13, in which quadrant do the following statement hold? When is the tangent positive? Remember, the tangent is, that's my graph. Okay, or I'm going back to my unit circle. And the question, where is the tangent positive? Here you can look at the problem in two ways. The tangent is either the sine over the cosine or the y over the x, because that's what the sine is when I am in the unit circle. So the question is, when is this positive? It's positive in the first quadrant, because in the first quadrant, if I take an angle here, the y is positive, the x is positive. So quadrant 1. Also, if I am in this quadrant, because in this quadrant, what happened? Y is negative, x is negative. So I have negative over negative and quadrant 3. Okay, so that's when the tangent is positive. And the tangent is negative in quadrant 2 and quadrant 4. Now B, the sine is positive and the cosine is negative. Again, when this is happening. Sine is negative, sine is the y coordinate. That's negative in quadrant 3 and 4. Now the cosine is positive, cosine is the x coordinate. This is happening in quadrant 1 and 4. If I want both of them at the same time, this should be in quadrant 4. In quadrant 4, the sine is negative and the cosine is positive. That's how you analyze the simple problem. Okay, and finally, I want the cosine to be negative, and the tangent to be positive. Cosine is the x coordinate. So that's negative in quadrant 2 and quadrant 3. Tangent is positive. We've done this, quadrant 1 and quadrant 3. So the answer here will be in quadrant 3. So in this quadrant, the cosine is negative because it's the x coordinate. The tangent is positive because the y is positive and the x, sorry, the y is negative and the x is negative. End of those problems. Right. Now I'm going to move to exam 2. So as I said, I'm doing part of those, not everything. So exam 2, there is something I would like to talk about, and then if I have time, I'll talk about everything else. So exam number 2 now, and I'm doing problem number 4, all right, because you guys messed up with that. And this is where the inverse sine and the inverse cosine come into the picture. So I'm doing exam 2, number 4. Exam 2, number 4, so you guys know what I am talking about. The question is, find all solution of this equation, sine t equals 0.6. And I want them only between 0 and 2 pi. So first, and the question is, mark your solutions clearly on the unit circle, and I want that. So I want to find, this is my unit circle. Okay, all right. And the question is, find all solution of sine t equals 0.6. Before I even find the solution, how many angles between 0 and 2 pi have sine 0.6? And in which quadrant are they? So I'm asking you the question. I want quick answers on chat. How many angles between 0 and 2 pi over 6 have sine 0.6? And in which quadrant are they? Question number 1 is how many? 2. And which quadrant? Here and here. And let us see why. The sine is the y coordinate. It means this is the 0.6. And what I am after there are 2 angles. What I am after is this angle here, I can call it T1, and this angle. There are 2 angles that have the same sine. So first we're gonna draw them. And they are in quadrant 1 and in quadrant 2. So this is, I'm gonna call it T2 just to distinguish them. Now how to find them? The sine inverse will give me the T1. The graph will give me the T2. Okay, so let's write this down. Sine t equal to 0.6. And I want your answer is in gradient. It means that one value of t would be the sine inverse of 0.6. That's the first value. That's the one my calculator will give me. Okay, which is equal to, I don't know if you guys can help me out a little bit. So this is the sine inverse of 0.6. It's giving me 0.6435. 0.64. I told you to round up to 2 decimal places. Okay, I'm gonna round up to do that much. Okay, all right. How can I find the second one? So T1 is the one I pick up from the calculator. So the calculator tells me, you know, if you take an angle of 0.64 radian, which is almost like, I don't know, 35 degrees, the sine of this angle is 0.6. How can I get the other one quickly? And this is, you have to use the unit circle. How can I get T2? It's nothing more than pi minus this little piece here. But this little piece here is the same as T1. So it's pi minus 0.644. Totally use the picture. And then you get the answer. Okay, because when I graded you, you guys just write pi plus pi minus 2 pi because you're not using the picture. And I'm always telling you, once you understand this, you're safe. But you have to understand that. Okay. 8. Find all the solution of cosine t equal minus 0.3 for t between 0 and 2 pi. Question number 1, how many angles are there? And which quadrant? Are there that have the same cosine? And the question is, which quadrant? how many angles between 0 and 2 pi have the same cosine? And in which quadrant are they? Okay, 2. There are 2 angles. And in which quadrant? If the cosine is negative, it means in quadrant 2, quadrant 3, that's what my angle is. Now we're going to draw the unit circle. There is no way I cannot think about those problems without my unit circle. Okay, that's my unit circle. My cosine is right there. This is minus 0.3. My cosine is the x coordinate. And I am after those angles. This one, that's one angle, and this one right here, the one in red. Okay, all right, these are the angles. So this is, I'm gonna call it T1, and then T2 is the one in red. Okay. So let us find them. So cosine T is minus 0.3. It means that's the one, the calculator gives me one of them. And the calculator will give me the one between 0 and pi. The calculator will give me one. So that's the one between 0 and pi. It means that's the cosine inverse of minus 0.3. And if I plug in this into my calculator, cosine inverse of minus 0.3, the angle has to be more than, the angle has to be between pi over 2 and pi. So I'm getting 1.875. Now remember, that's in radian. To give you an idea, 1 radian is almost 57 degrees. To make sure that you're doing it right. So 1.8, you're hovering around 119 degrees. So we are right there. Now, what is the T2? Now I go back to my picture. All right, I know this angle. So this T1, this one here is 1.875. How can I get the red one? Just you look at the picture. How can I get this one? Okay. One way you look at it, you say, by symmetry, there are several ways of doing it. One easy way, you say, okay, if this is 1.75, it means this here also should be 1.875. So my angle is going to be 2 pi, take away that. That's what it is. Okay, and then we're done. Then we get the answer, all right? So these are the 2 angles between 0 and 2 pi. Now my second question is between 0 and 4 pi. And this is, at this stage, it's not becoming hard anymore. So if I compute that, let me see, I computed just to have an idea. So I'm getting 4.407 almost. Okay, now between 0 and 4 pi, okay? Once I find the angle between 0 and 2 pi, then I am done. Because this is my T1. Its cosine is minus 0.3. Forget about that. Means if I take this angle and go around the circle to pi, up to here, I'm going to have exactly the same cosine. So that's T1. Another one would be 1.875, add 2 pi to it. Then I will get another one. If this is my other angle, T2, and then we add 2 pi to it. If I want angle between 0 and 6 pi, I keep adding 2 pi's to that, because adding 2 pi will not really change at all the picture. One other problem, I would like to go over it with you, and then you guys will be actually on your own. Okay, this problem is along the same ideas. Could you do a general overview of sine? Caitlin, can you speak up? Caitlin, tell me exactly what you want.
I just wanted to go over when to use either the function or the inverse function, and specifically which situations we know when to use which one, if that makes sense.
You always have to use the inverse to find one angle.
Okay,
And
so
then you
inverse
use
is
the
just-
picture to find the other angles. Am I answering your question or no?
So the inverse is when we need to specifically find the angle.
One of them.
Okay.
You need that. But
Okay.
you know that there is more than one. That's when you use the picture.
Right.
Are
Okay.
you with me?
Yeah.
Okay, the sine inverse gives you only, that cannot give you, like when you plug in sine inverse into your calculator, it's going to give you one value. It doesn't give you everything. But when we took those problems, let me go back to the problem we did. Actually, okay. When I took those problems, sine t equal whatever, I don't know, 0.6, right?
Right.
So this is my circle. Okay, I want to find the angle. So that's 0.6. Between 0 and 2 pi, I have two of them, this one and that one. Right?
Right.
Okay, but I need at least one of them. The sine inverse gives me one of them. It doesn't give me all of them. The sine inverse gives me the one between minus pi over 2 and pi over 2. It gives me one. It's up to us to figure the other ones.
Right.
So the calculator would give me that. And then to find the other, I use the symmetry. I said, those two angles are equal. That's the total symmetry. So if I know this one from the calculator, the other one is going to be pi minus it. Is this making any sense?
Yeah. And specifically, you would use just regular sine when you're trying to find the coordinate, whereas sine inverse.
Yeah, that's different. Oh yeah.
I'm just making sure I have it all.
Yes.
clear.
If I give you the angle, right? So there are two issues. If I give you the angle, I tell you this is pi over, I don't know, I just make up something, pi over 5, okay? And I give you this a 3. If I want you to find the point, you use 3 cosine pi over 5, 3 sine pi over 5. Okay? Now, if I give you the sine, I give you the coordinate, and you want to find the angle, the problem becomes a little bit different because there are more than one angle. There are actually a lot of, infinitely many of them. The sine inverse gives you one. The picture gives you the other one. And then you start adding 2 pi's or taking away 2 pi, you get all the others.
Okay, thank you. That answers my question.
Is it? Okay. Right. Now I will look at number 12 because it's along the same line. And then I wish you luck. So here I have the baseball field usage. And you definitely have problems along those lines, plus everything else. The baseball fields usage in people per week is seasonal, of course, with the peak in mid-July and low in mid-January. Let f of t represent the usage at time t months after mid-January. So 0 corresponds to mid-January, and that's the baseball usage. So at every time t, they're telling you how many people per week are using it. Okay. So the graph of f is given below. Question is find amplitude, midline, and period. All right, so I gave you the function this time. It's given to you. You have to find the amplitude, the midline. So the amplitude, this is not hard. Amplitude is the 750. Okay, that's the amplitude from here. That's give you the midline. Midline is y equal 1250. This will give me the midline and the period. Now let us be very careful. Where is the period? The function is pi over 6 here. So the period, I will write the function in front of me because it makes it easy for us to find. So the function is minus 750 cosine pi over 60 plus 1250. So the period is, even though it was clear from the graph, but sometimes I will not give you the graph, so we have to find the period. It's 2 pi over the b, which is the pi over 6. It means we use fraction times 6 over pi, which give me the 12. So the period is 12. It means it takes 12 units. That's a year. And then the cycle starts repeating itself. Okay. So this is my 12 here. So now, and this is my max. And this is my mean. And 1250 is the midline. So I'm going to draw the midline here the best I can. This is 2000. This is 1500. So the midline should be, no, that's, yeah, 1250. That's the midline. Okay, that's really my midline. So that's 1250 here. Okay, so this point is the 6. This is the 3. This is the 9. And this is the 6. All right. Now, question number 1. Find the baseball usage in mid-March. It means at t equal to 2. So in this problem, I'm just asking you basically to plug in 2 inside the formula. Because I'm telling you, okay, for t equal to 2, how many people per week were using it? So this is simple. I don't remember, my memory is that you did not have trouble with it. Times 2 plus 1250. So this would give me minus 750, the cosine. So first I simplify here. Pi over 6 times 2 will give me pi over 3 plus 1250. And then we evaluate this using our calculator. So I'm going to do that. Minus 750 times the cosine of pi over 3 plus 1250. So I'm getting 875 people per week. Okay, so in mid-March, that's how many were using it. Now part 2 is find all the values of t when f of t equal 1000. It means when will we have 1000 people per week for which value of t? And here I'm telling you, find one value using the arc cosine and the other value using the symmetry in the graph. And make sure you show your answers. Okay. So now what the question is, you're going to find t. Sorry. You're going to find t such that f of t, it means we're going to set f of t equal 1000 and we're going to solve for t. Okay. All right. So we're going to set f of t equal 1000. So this is minus 750 cosine pi over 6t plus 1250. It looks hard, but actually it's not. Equal 1000, and I need to solve for t. Okay, so we need to isolate the cosine to be able to solve for it. So I'm going to take away 12,050 from both sides, which would leave me with 250. So I took away 1250. I need to isolate this term to be able to do anything. Will be minus 250 over 750. Now this could be like simplified a little bit because the 0 can go and I can divide by 50 across by 5. So it should give me 5, and this should give me right? No, 25. Yeah, actually I can do better than
Negative
that.
1/3.
Or negative 1/3. We can do better than that. Okay, let's give me negative 1/3. So it means that the cosine of pi over 6t equal negative 1/3. If we do a little bit of math. But this gives me that. I want to use the arc cosine. So I know the cosine. I need what's inside. I need the angle. And there is one way out. Arc cosine would give me that. So this gives me that pi over 6t, be very careful, is the cosine inverse of minus 1/3. It's the pi over 6 because that's what's inside. And now the rest is, it means pi over 6t equal cosine inverse of minus 1/3. So that's the cosine inverse of minus 1/3. Okay, I did something stupid, I guess. Cosine inverse of minus 1/3, it's 1.91. Okay, I want the t. So you can multiply by 6 over pi, or if you want, you can divide by pi over 6, whichever you're comfortable with, which is the same thing as times use property of fraction, 6 over pi. And that's what gives me the t. And this gives me one value of t. So 1.91 times 6 over pi. I'm getting 3.64, almost 3.65. Okay, now I'm gonna go back to the picture and elaborate this in the picture. I hope I'm not doing any stupid mistakes. And the solution is on Brightspace, so you guys can check it out. Now I'm gonna take you back to the picture to really analyze what's really going on. I feel the answer is not right. Anybody try to do that? Anybody try to do anything? Somehow the 3 doesn't really sound correct for me. Anybody can check any mistake. I feel that the 3 is overboard. It should be like 2 point something. Let me check that again. Inverse of minus 1/3. Anybody see anything wrong? Okay, the math makes sense. Something is, okay. It should be less than 3, because if I go back to the picture, this is 1,000 right here. So this is 1250, that's 1,000. And my question is when this is occurring. Okay, so it should occur, that's 1,000, right? Okay, everybody tell me it's right, but I feel there is something not right. Okay, I will check my solution. This is 1,000, this should be here. And this is where the population is equal to 1,000, all right? Now, I don't know where I'm getting here. I should get less than 3. Give me 1 second. Did you guys check the solution? Because I'd hate to do something that's bothering me. Yeah. Okay, all right, okay. Now that's the mistake because I knew something. You guys should, okay. All right, 1,000, this should be a minus. That's where the mistake is. When I took 1250, this should be now a plus. That should be a plus. You guys should be watching. That should be a plus, okay? And this should be, because it didn't make sense to me at all, this should be okay, this one. And now I am in the right shape. Cosine inverse of 1/3, sorry, Sorry about that. That's going to give me 1.23. That's the answer should be here. This should be 1.23. So that was my mistake. And then my t should be 2.351. Okay. Now, how did I know immediately that I have a mistake? And I should tell you that. How did I know I did something wrong in the math? Let me take you back to the picture. That's what struck me. I'm finding the time when f of t is 1000. So that's the output. And I'm finding the time when it is 1000. So when I draw my 1000, I realize that t is less than 3. That's why I realized that I have something that's not really working. So this is my t. So this is the 2.351. And now I want the other one. Now I look at the picture. This is 2.351. The symmetry tells me that this is 2.351. So I can use total the symmetry. And my other value is going to be 12 minus 2.351. And that's the other value I'm going to have, which is going to be 9.649. Okay. All right, so these are the problems that you guys as a whole struggled with. So please, this is not everything. Go over your quizzes, go over your exam. There is a lot to work with. You will have problems, of course, along those lines. You will have problems along the first page of exam 2. It means review the law of sine, review the law of cosine, review the definition of sine and cosine. And then the other thing you will have is like the polar coordinate, of course, and you will have the ellipses and circles. Okay, the best of luck. You guys can start your quiz. And if you have any questions, please write on Brightspace. Good luck.